Welcome back to DentChem. You've tried this problem now, you have your answer ready, and I'm sure it's going to be great. Let's go over it right now. So we're looking for Sterocenters, and all we need to do, remember, is look for 4 distinct groups. Methyl group here, 3 hydrogens cannot be a Sterocenter. They need to be different. Same with this one here, 3 hydrogens cannot be a Sterocenter. This group here, at the end of our wedge, so we kind of had this ethyl group sticking off, or rather this would be our longest chain, so this would be a methyl substituent here. Just because there's a wedge or dash doesn't mean I have a Sterocenter. And if I look at this carbon here, I see I have 2 hydrogens not explicitly drawn in, cannot be a Sterocenter. Now let's look at this carbon. I do have a wedge or dash, but again, that does not mean Sterocenter. I just need to follow that one rule. Do I have 4 different groups? This carbon has an ethyl group going up, a methyl group to the left, so those are different, a hydrogen not drawn in, and then this entire carbon chain to the right. Those are 4 different groups. Methyl, ethyl, carbon chain, and hydrogen. This is in fact a Sterocenter. I didn't determine that just because there was a wedge there. I made sure and I checked using that one simple rule. Next carbon up, 2 hydrogens, cannot be a Sterocenter. Here we have chlorine with a dash, meaning it's going back. Do I have 4 distinct groups though? I do. I have 2 different carbon chains, a hydrogen not drawn in, chlorine atom there. This is in fact a Sterocenter. So we have 2 Sterocenters right now. Here and right there. We'll keep moving to the right. Here, I have the carbon chain to the left. I have a hydrogen not drawn in. And then I have these 2 carbon chains down here. If you notice, they're the exact same though. This is not a Sterocenter. If I take this carbon and I try and distinguish between these 2 chains that form the ring, they make the same bonds. Carbon, secondary carbons, the same carbon and chlorine. The chains are the exact same. There's no difference. And all we need to do, remember, is that one rule. Do we have 4 distinct groups? In this case, no. These groups connecting to this carbon are the exact same. CH2, CH2, and so on. Okay? So those are going to be the exact same. Not a Sterocenter. Rings are more commonly you're going to see that with, but in any case, even if it just splits off into a couple methyl groups, if they're the same, it's automatically not a Sterocenter. We'll go up here, 2 hydrogens, not a Sterocenter. And we can go along that along our ring. All of these secondary carbons here have 2 hydrogens not explicitly drawn in. Because those hydrogens are the exact same, we can't have 4 distinct groups. None of those are Sterocenters. And now we'll look here at this chlorine. I have a wedge, so I can say it's a Oh, I can't quite do that. Remember, I need the 4 distinct groups. Don't let the wedges and dashes fool you. Chlorine's distinct group. Hydrogen, that's a distinct group. Now this is not going to be a Sterocenter for the same reason this one wasn't up here. If I look at these 2 carbon chains and I try to differentiate between them, I can't. Carbon, 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 and then they're the same chain after that. So I don't have distinct groups there. I only have 2 Sterocenters on this entire molecule. Okay? Hopefully that was good practice. It's an easy easy setup and easy problem to practice with others, so I encourage you to do that. I also encourage you to like this video, subscribe to DentChem, and make OChem easy. Thank you for watching.